success. And I think the project was quite a success. We also have we did another project that was for battery bank installation. This was for Bujagali in Uganda. Then we also had a battery bank testing project. This is in Olkaria for Kengen. Then in Bugesera, Uganda, we also had, in Rwanda, we also did a transmission line testing project, as you can see there in the picture. We also have done supply, delivery, and installation and commissioning, as well as training for Tanzania Bureau of Standards for their labs, where we supplied them with a range of calibration equipment. We also did a similar project for Ejenko in Malawi, where we delivered, installed, and commissioned some equipment, as well as did training for some electrical test equipment. And why work with us? Maybe you may be wondering why choose Amotech, because we have a qualified team of technical sales engineers who will work closely with you and walk the journey with you from the time you identify your need to the time we are able to deliver a solution to you and train you. And we do offer a warranty on our equipment, and we support with repair and calibration should there be a need for that. We also are locally available, so we will be available to come to you. If you need a proof of concept, we'll be able to provide that for you. And through this kind of support, I believe you are able to get maximum return on your investment for whatever solution you acquire from Amotech. So these are our contact details in Kenya, physical contact details in Kenya, in DRC, and in Tanzania. Thank you very much. As I mentioned, Alex is on this call. He's the technical sales engineer for Andritsu, and I believe that he will be able to say something shortly. Welcome, Alex.
Okay, thank you very much, Kathy. As you've heard, my name is Alex Njoroge. By profession, I'm an electrical and electronics engineer, and I work here in Amotech, the great team, and I am in charge of the product of Andritsu, and we are happy that today we are joined here by Andritsu representatives, and we have a keynote speaker, and I'll proceed, without further ado, I'll proceed to introduce him so that you can start the webinar. So Marwan graduated from the American University of Sharjah, AUS, with a bachelor's degree in electrical engineering and a specialization in telecommunications and electronics. He has 2 published journal articles related to millimeter wave 5G measurement, and he has worked in the research and development as a graduate research engineer, where he was responsible for designing and testing of 28 gigahertz millimeter wave channel sounder. Marwan has also worked with the civil engineering department at AUS, that is the American University of Sharjah, to test penetration and reflection of conductive concrete at high frequencies. Among his hobbies include football, volleyball, and snooker. So without further ado, Marwan, you're welcome. The stage is yours. Thank you.
Thank you, Anis, for this introduction. So what I'm going to do now, I'm going to share my screen, and Alex, please, if you can confirm if that my screen is visible, and then we can start with our webinar.
Yes, your screen is visible. You may proceed.
All right. So welcome everyone to this webinar about spectrum monitoring. So this webinar will be hosted by me, Marwan Al-Bardisi. I'm the business development engineer at Anritsu. This webinar is being done in partnership with Amotech, our partner in Kenya. Basically, the agenda of this webinar, I will be going over a brief overview of spectrum monitoring. Then I will be covering some of the applications of spectrum monitoring. Then I will be presenting our own spectrum monitoring solutions. Then I'll move on, of course, when we're talking about spectrum and spectrum monitoring, there will always be interference. So I will mention how to detect this interference, how to locate, characterize this interference. Then, of course, I'll move on to how our products can help you identify and detect and analyze this interference. And finally, I'm going to go over how our products also do signal identification and analysis. Then I'll end it with a brief summary of all the slides that we're going to mention, and hopefully we will have some time for questions and answers. So starting with an overview about spectrum monitoring, basically there are three main questions that may come up when we're talking about spectrum monitoring. What can I do with spectrum monitoring? What are the applications of spectrum monitoring? And finally, what kind of system features do I need in order to do this spectrum monitoring? So starting with spectrum monitoring, there are five main models that are used for remote spectrum monitoring. The first one would be real-time remote spectrum monitoring, which allows the technician to be on site in multiple locations. And when I say on site in multiple locations, I mean he can be in his office working remotely from the desk, and he will be connected directly to each of the remote spectrum monitoring stations, and he will be able, of course, to see every channel at each location directly from his desk. Then there's, of course, spectrum recording, which allows the technician to review any interference. For example, in case of an event like a festival or a concert, spectrum recording, of course, is very important so that we can try to review any events that may occur if there are no technicians available on site. Then, of course, there is alerting, where basically we can set up an alert or a limit line on the spectrum, and of course, this would send a notification to the concerned person, because of course you cannot really expect a technician to be sitting looking at a spectrum 24 hours, 7 days a week, looking at a spectrum. And this is how making an event to send a notification in case some channel goes missing or some channel goes below the specified level or above the specified level, or an unwanted unknown channel shows up on the spectrum. That's when an event could be triggered, and the technician can then start taking some action. Then, of course, there is location finding, and this is done by triangulation. And of course, this allows the engineer to sort of estimate the location of where the interference is happening. And in order to do this, there must be set up at least three different spectrum monitoring stations across a certain area or a certain field. And through that, the technician would be able to determine or get an estimate or where the interference is coming from. And later on in the slides, I will show you exactly what are the different techniques, what are the different technologies that can be used in order to find this location. And finally, there is the option of signal analysis and demodulation. And this is, of course, for quality analysis of your signal, trying to demodulate your signal. For example, in case of cellular signals, you have the option to demodulate the 3G, 4G, 5G signal, and looking at all of the different measurements and quality analysis features. So then, why is spectrum monitoring important? First of all, in order to identify and locate sources of interference, spectrum monitoring is very important. As you can see here, this is one spectrum monitor, and they are connected to different remote spectrum monitoring stations, and they are monitoring them all at once. It's also important for dynamic spectrum sharing. It's also important for policy making, whether it's by the national regulators and when ITU, for example, makes its own regulations. Of course, it's also useful in the operations, whether it's commercial or in government, whether we're talking about airports or prisons or concerts, or for also in terms of broadcasts, in terms of a news show or a football match, or any sort of event, really. And of course, for military and enforcement purposes, where if you have a secure room and you do not really want any interference to happen, no eavesdropping, no signal should be coming in or out. So this spectrum monitoring is very important, and as you can see here, it has many different aspects, many different applications, and which actually takes me to the next part of this presentation, which are what are the applications of spectrum monitoring. First one would be spectrum clearing. And when I say spectrum clearing, basically it means that when there's a new technology, let's take 5G, for example, and it's about to be released to the base station operators or to the mobile network operators. Of course, the regulating authority would need to, first of all, allocate a certain bandwidth, a certain frequency to those to this technology. And in order to do that, the spectrum has to be cleared. They need to make sure that there is no one using this this specific band. And of course, it's also useful because of course, in order to obtain a license, you have to pay the fees, and then you have the channel blocked for for this use. And in some cases, then the customer would come back and complain that actually the channel is not really clear. Some old users are still using this channel, and so on. So spectrum clearing is very important, just to make sure that no one is using the spectrum that's being allocated for a new service. That new service can be something permanent, like a new cellular technology. It can also be something temporary, like a concert, for example, or some event broadcast that they need the spectrum for a temporary amount of time, and then it can be released.
I'm wondering if it's still good, like, yeah.
Then one other application of spectrum monitoring is, I'm sorry, someone needs to mute their mic.
And I'm the host, but also Alex is a host, so I think we are funny.
One other application of spectrum monitoring is shared spectrum. Of course, when a spectrum is when a spectrum is being released, of course, the sources are scarce, and basically we cannot always allow all users an infinite amount of spectrum. The resources are sort of limited, and this is why the spectrum is usually shared. And of course, operators need to be aware of this case. And of course, in the case of shared spectrum, spectrum monitoring is important in order to give certain criteria. So for example, if we look at this example here, when we're looking at the channel occupancy, for example, we can see that yes, in this area and in this area, the channel is heavily occupied, but we can see that there is some unused spectrum that can be shared to other users. One other use is that, for example, whenever a national regulating authority or even private users, they need to know which channels are occupied, or even what is the average noise level at this specific band. This is where spectrum monitoring comes in, If we look at this picture here, we can clearly see that the noise level has a clear drop at this specific band. And this is allowed, this is enabled using spectrum monitoring. One other application of spectrum monitoring is, of course, satellite ground station. Satellites are a big market for spectrum monitoring. They always need uh, a lot of measurements. So we know that satellite downlinks are generally moving towards higher uh, frequency, whether it's for research or for TV broadcast. And of course, they are highly susceptible to interference from many different for many different reasons. And of course, continuous 24/7 monitoring is required in order to maintain a continuous communication. And generally, there are a lot of satellites nowadays, and orbital congestion is a big problem, especially in the satellite and the SATCOM area. And of course, constant spectrum monitoring is always required, and they usually do so many different measurements like cross-polarized isolation or the spectral shape of the downlink. Sometimes even illegal carrier-in-carrier broadcasts. They also measure some modulation parameters. Spectrum monitoring also allows, like I said earlier, to set up alerts either for missing or additional carriers that are showing on the spectrum. Spectrum monitoring allows you to monitor all of these measurements. The final application I have for you today is, of course, to predict events and festivals. Of course, an event manager will need to make sure that the spectrum is clear. There are no interference. There is no illegal broadcasting. And also in case of broadcast, there are multiple microphones, radios, and broadcasting equipment. And we need to make sure that all of these equipment are operating in their own band. There is no intermodulation. There is no cross interference, and so on. So then, after we know these applications, so what are the system features that are needed in order to do good spectrum monitoring? Of course, there are many different applications, whether it's inside or outside. And this is why the system would have to meet several requirements. Starting with, it needs to have a wide range to cover most of the frequency spectrum to use, ideally up to 43 gigahertz. It needs to be reliable. It shouldn't be affected by weather or potential power drops. It needs to be easy to use. It needs to be user friendly. It shouldn't be very complicated to deploy a spectrum monitoring network. It needs to be relatively small or not to have a footprint. So we wouldn't need to be built for it a special room or a shelter in order to put this equipment, whether it's indoor or outdoor. And it needs to be easily integrated, of course, into the network, whether wireless or wired or LAN and so on. Ideally, of course, you need some sort of automatic operation and alarm generation, and this is when you need to set up some alerts, like I said. So the spectrum needs to be monitored at all time, and you need to set up some automatic operation in order to make sure that everything is going well. Also, shouldn't be very expensive, and ideally, it should be scalable and have some audio streaming and recording features as well. So now that we know what are sort of the features that are required, I would say these are the minimum or the most optimum features that are required for to do spectrum monitoring. Now, I'm going to present to you what are the solutions that Anritsu provides in order to our remote spectrum solutions. Our first one is the MS27101A. This is a 6 gigahertz remote spectrum monitor. It has a single RF input port. The second one is the 102A, and the main difference between them basically is that the 102 is IP67 rated, so it can be deployed outdoors. It can withstand being submerged up to 1 meter in rain, and it's also dust resistant. And it can support up to 6 RF input, up to 6 RF input ports. The next one is the 103A, and this one also goes up to 6 gigahertz, but this time it can either support up to 12 or 24 RF input ports. This device would be useful, for example, in case of a broadcast agency where they have multiple antennas, or an airport, of course, with multiple antennas, and they need to monitor all of them at the same time. So this device would be beneficial for them. And then finally, we have the newest one, which is the 201A. And this one goes up to 43.5 gigahertz. There are different frequency options on it. So it goes up to 9 or 20 or 43.5 gigahertz. So we're gonna look at some of the main key features and highlights of the one series remote spectrum monitors. So like I said, they can go up to 6 gigahertz. They have a very fast sweeping speed, so 24 gigahertz per second. They have a relatively high dynamic range, up to 106 dBs. The displayed average noise level is all the way down to minus 165 dBm, and this is, I would say, it's a very good noise level. So even the weakest signals, you'd be able to see them clearly. The spectrum trace can show up to 4,000 different points. The instantaneous bandwidth is up to 20 megahertz. They have an integrated preamplifier on the device and 4 gigabyte internal memory. There is also the option of IQ capture and streaming. And it also supports the vision software with the vision monitor and the vision locate. And I have some specific slides just about the vision software that I'll go over in the next coming slides. Now, for the main features of the 201 series, like I said, this device can go up to 43.5 gigahertz. It also has demodulating capabilities for 4G and 5G, so you can demodulate the signal and look at all of the different features like measurements like cell ID, broadcast power channel, and so on. It also has IQ capture and streaming. And the phase noise of this device is down to minus 110 decibels compared to the main carrier. And it has an adjustable RBW between 1 to 10 megahertz. And similar to the 1 series, the displayed average noise level also is down to minus 100 and minus 164. So now the vision software, basically, this is a software that is installed on all of our remote spectrum monitoring solutions. It has many different features. So basically, you can start with one PC software that has the vision software installed on it. And through that, you can then connect to many different remote spectrum monitoring devices all at once, and you will be able to monitor all of them in real time from one station. So the vision monitor software allows you to monitor 24/7 all of the stations. And not only that, you can also set different acquisition settings for each of the probes. whether that's frequency range, RBW, VWW. You can also set up limit lines and generate pass-fail reports for each of the stations. There is also the option of 30-day trace history, and this is of course important in order to generate sort of a statistical history as to how the spectrum behaves over a certain amount of time. And of course, you can use this to estimate any source of interference and finally generate some reports. Some of the functions of this software includes editing probe information and scan settings. You can look at multiple live data from multiple probes. You can add limit lines and apply sort of historical data to see how the behavior changes over time for each of the channels. And finally, you can generate some pass-fail report and see how the signal has behaved over a specified amount of time. For here, you can see I would say the software in full view, where we're looking at the spectrum, we're looking at the historical sort of histogram view, and we also have the list of all of the different channels that we assigned to this software. Then, of course, there is the locating vision software, which uses different technologies, and this is what I was talking about, how the software can enable you to estimate the location of the interference. So there are different technologies for that. The first one would be the power difference on arrival, the PDOA, and this is of course based on past trace recordings, and it works basically that it forms a triangle over which we would say that yes, the interference is somewhere within this triangle. Like I said, we would need at least 3 RSMs to be deployed in order to use PDOA. The second one is TDOA, which is time difference on arrival, and this is used basically in case the interference is not located within the network, it's not inside the triangle that's formed with our devices. So then TDOA would allow you to sort of give you an estimate of where this interference is coming from. The final one is basically before the last one actually is basically antenna sector based, and basically the software would know where the antenna is looking at. So for example, if I have one antenna covering this area and I have one other antenna covering that area, so basically I can with some confidence say if the signal is being caught at all of the antennas, that whatever common sector between the antennas is covered, that's where most likely the interference is coming from. And finally, there is the option of the API interface for geolocation. And of course, this is it's easily integrated into other software platform. And you can see here, this is a screenshot of the vision locate and how it's capturing data from different remote spectrum monitors and estimating the location of the interference. Now that we're talking so much about interference, I think we should at least cover a few minutes at how interference should be detected, identified, characterized, and of course, located. So in order to do interference analysis, there are 3 main steps, I would say, that are required. First of all, you need to identify, or you need to spot that, yes, I do have interference. The next step would be characterizing the interference, and finally, you would set up with your gear, and then you can start with the interference hunting. So starting with spotting the interference, first indicators would be that there is some noisy link, or there is, in case of digital transmission, there is a low throughput. In case of cellular transmission, basically the noise floor would be maybe too high, or there would be an increased call drop rate, or in some cases there will be this waterfall sound in the background, or in case of broadcast there will be some complaints from the users. So these are sort of the first indicators that yes, I do have some interference in my system. So then before we really go and do interference, first we need to ask some questions about this interference. Is it an on-channel interference? On-channel can happen from many different reasons. Frequency reuse, cell overlap. The antenna might be tilted due to the weather, or in some cases, if there is a water body, so the propagation of the signal would be increased, or it would behave in an unexpected way, and then interference would happen. Is it an in-band interference? And this could be due to other carriers. Even if they're operating at a different channel, they could have some in-band interference. Is it an impulse? Is it impulse noise? This could be due to electric motors or welders, or some electric fences and power lines. Is it harmonics? And this could be due to broken transmitters or broken amplifiers. Is it passive intermodulation? Passive intermodulation can be due to rust or faulty equipment. Is it the near-far problem in case of emergency services, or an ambulance passing by? And of course, there is the high case that it's actually intentional. And intentional, it could be like a jammer. Maybe a car is passing by with a jammer that detects radars, or it can be in a military application. You're close by a military site, and they're sort of cutting off interference at all of the surrounding area. So then basically what can you do? Basically you can check for the interference at both sides, make sure that the noise level at both sides is the same, and then get a visual ID on the signal, characterize this signal, and this is useful so that when you go interference hunting. So then now, how can we characterize this signal? Basically, there are three main things that you need to look out for. First of all, you need a visual recognition of the signal. You need to see how its RF spectrum looks like. You need to see its frequency, its bandwidth, its power level, its overall shape. You need this information so that when you go out in the field, the signal behavior might change, and then you need to keep track of this signal. Then in case of analog or digital modulation, you can actually demodulate the signal. In some cases, if it's an analog modulation, you can demodulate it and then listen to this interferer, or maybe you can demodulate the cellular signal and figure out the cell ID of this interferer. And finally, which is very important, you need to characterize some time-based behavior of the signal. When does it occur? Is it triggered by external events? Now, external events can be many things. For example, like we see here, there's a policeman using his push-to-talk device, or maybe a car is passing by with a jammer. In some cases, for example, a gas station, at the end of the day, they're sending back their receipts of the day. There's a nearby university or a nearby lab that's doing some RF testing. So you need to monitor this signal for an extended period of time and figure out how does it behave. Is it constant? Does it go? Is it only appearing at a certain time of the day? And this is, of course, important. It's an important characteristic of this interference. So now that you've characterized your interference, you know how it looks like, then you can start, of course, interference hunting. So what do you need in order to do this interference hunting? First of all, you need a wideband spectrum analyzer to cover a wide range of frequency, because In some cases, the interferer can be jumping from one frequency to the other or jumping from one channel to the other, and you need to make sure that your spectrum analyzer covers this wide range. And you also need it to be fast so that it doesn't miss any bursty. And when I say fast, I mean as close as it can be, of course, to real time. You need a real time spectrum analyzer, unlike the FFT based spectrum analyzer that has a very low probability of intercept, so that even the smallest burst of a signal should show on the device. You would also need some historic record or a spectrogram on the device, and this of course provides a record of how the signal has been behaving for a specific amount of time. And then finally, of course, in order to actually locate the source of interference, you need a directional antenna, whether it's a Yagi antenna or a log periodic antenna. Of course, it needs to be in this frequency range. And basically, these are the tools that are needed to do a successful, I would say, interference hunt. And now this is where I would like to introduce our Anritsu's Fieldmaster range. So we have the Fieldmaster Pro, the MS2090. This one has all of the features, and it covers all the way up to millimeter wave 54 gigahertz. Then there is its two little brothers, I would say, the 2070 and the 2080. The 2070 covers up to 3 gigahertz, and the 2080 covers up to 4 gigahertz, but it features also the one I was talking about earlier, the RTSA, which is the real-time spectrum analyzer, and it can also demodulate 4G and 5G. Finally, this is one of Anritsu's patented devices, the ultra-portable Spectrum Master. This device is almost as big as your smartphone, and it has a very high frequency range. It can go, there are different options, of course, but it can cover all the way up to 170 gigahertz. So the product I'll be focusing on is actually the 2090. I'll be going over some of its key features, its applications, and so on. Starting with the frequency range, it can go up to 54 gigahertz. Of course, it depends on the option. You can start with 9 gigahertz and go all the way up to 54 gigahertz. It also has a real-time spectrum analyzer, and the real-time spectrum analyzer's bandwidth can be 20 as standard, or you can go for the option of up to 110 megahertz. It has a displayed average noise level of minus 164, which again is very good, especially for signals that are very low in power. It features IQ capture and streaming as well, and this is a very good feature, especially for VSA, which I'll cover in the next coming slides. It also has pulse and EMF measurements, and it also has the coverage mapping option. Where can this device be used? It can be used, of course, for interference hunting and spectrum clearing network, broadcaster transmitter analysis, cross-border interference, microwave radio links, pulse radar measurements, satellite system monitoring, and of course 4G and 5G base station measurements and coverage mapping. It also features the RTSA, which is the real-time spectrum analyzer, and the spectrogram. And this is how the RTSA actually looks like on the device. Unlike your normal power versus time display, the RTSA actually plots sort of this spectral density, because the device is doing 500,000 FFTs per second, and this is way too fast for in order to see one sweep at a time. So the device actually shows a density of how this power is received over a specific frequency range. And as you can see here, this RTSA is actually used in order to detect or locate the SSB in the 5G carrier. And over here, this is how the spectrogram looks like. And this is what I was talking about when the spectrogram sort of gives you a history of how the signal has been behaving over a specific amount of time. And you can see here, of course, the frequency hopping nature of the Bluetooth. The device also supports our own interference hunter, the MA2700, and this device, of course, is the ultimate tool for interference hunting. It has its own preamplifier. It has its own e-compass, which is very important, and I will show you why later on. And it covers most of our antennas. And it has this trigger, and I will show you why this trigger, of course, is important. Ideally, this is how your interference hunting gear should look like. So you have this shoulder harness to hold the device. And this is, of course, important so that you will have one hand free to manipulate the device. And on the other hand, you have the interference hunter with at least one directional antenna connected. And the way that it works is you would load up the interference hunting application, and you would start scanning around, looking at the device, seeing at where the highest power received of this interference is coming from. And when you do that, you can then press on this button and trigger it. And what will happen is a line will be drawn on the map indicating that, yes, I am receiving the signal at this location. And then what you can do is then move on to a second location, and again start scanning, seeing where the signal is coming from at its highest power. And then when you find it, you can trigger it again. Then you can repeat it for a third or a fourth location, whatever it is. And then finally, you can say with some confidence that I am receiving this interference from this location. You can also split up the display so that not only are you looking at the map, but you're also looking at the channel power measurement. One other very good feature is the polar plot, and this will allow you, for example, you can then go in a 360 holding the device going around, and then the polar plot will be plotted on the map. And it's useful because in this case, in this example we're looking at here, we can clearly see that we are receiving this interferer from two different locations. So we can say with some confidence that there are two sources of interference in this case. One very good feature about this device as well is that it supports cable and antenna measurements. And basically, when you're doing not only if you're monitoring the spectrum outside of your antenna setup, but also you need to measure the performance of your cables and the performance of your antenna. You need to do some VSWR measurements, or return loss distance to fault. Of course, a spectrum analyzer cannot do all of these. You would then need a cable and antenna analyzer or a site master. And this is where we've actually integrated our very own ultra portable site master. You can see here it's a very small device. You can connect it directly into the cable or into the feeder cable of the antenna, and then the MS-2090 would actually start the sweep with the cable with the site master, and then basically you can view the performance of this setup. Then for signal identification and analysis, the MS-2090 also has 4G and 5G demodulating capabilities. This can be either connected directly or over the air, and it would allow you to do all sorts of measurements like the cell ID, sector ID, the physical broadcast channel, or the synchronization channel, signal quality, adjacent channel leakage ratio. And there is one feature that we launched recently, which is DSS detection, which is dynamic spectrum sharing detection. And this, of course, you can see it here. If the 4G is actually, if of course, in case of 5G non-standalone, where the spectrum is being shared between both 4G and 5G, the device can detect that, and then it can tell you that, yes, I detected NR, new radio, 5G new radio. It can also demodulate 5G, and this is, of course, again, it has all the features like the cell ID, sector ID, the signal synchronization block, which has information like the reference signal received power or the signal to interference noise ratio, or the equivalent isotropic radiated power. And of course, these measurements are very important in order to do quality analysis on the device. And like I said before, the device also has IQ capture and streaming, and this is very useful, especially for VSA, which is vector signal analysis. The vector signal analysis, of course, then enables you to do a whole other segment of measurements, which includes the constellation, EVM, magnitude symbol, the histogram or the eye diagram as well. And the way that it works is that you would connect the IQ enabled device to the PC. The IQ data would be transferred to the PC, and then the software would take in this data and opens up a whole other vector signal analysis capabilities on the device. So to summarize what we've been talking about for the past 40 minutes, I would say spectrum monitoring is very important, and it has many applications, not only commercial, but also for government applications. There are different applications for spectrum monitoring, which includes spectrum clearing, satellite communication, events, military and critical infrastructure, of course. And this is our devices that support the spectrum monitoring. And of course, when you detect an interferer, or when you want to characterize your interference, basically you need to figure out and identify and characterize the interference. You need to look at its RF characteristic. You need to see if it has any behavior through time. And of course, you need the ideal tools to do interference hunting, that being an RTSA, real-time spectrum analyzer. And of course, it would be very beneficial if it was equipped with a spectrogram. And finally, a directional antenna to support you during this interference hunting that you need to do. Thank you, everyone, and please, if you have any questions, I'd be more than happy to answer. Please, you can leave them in the chat or post them in the Q&A section of this event.
Thank you so much, Marwan, for a very comprehensive presentation. Very interesting as well. I think now we will open up the session for some questions. There's a question about whether people will receive this presentation after this.
Yes, I will. I can share this one with. I will share this presentation with Amotech, and then of course they can share it with all of the attendees.
Okay, thank you for that. That was the main question. I don't see.
So it looks like there are no other questions. Yeah, so it looks like I did a very good job in delivering
you did a
the
very
information.
good job.
So
yes, you did.
Yeah, thank you everyone for attending this.
Oh, there is a question. Sorry.
Yes.
Oh no, sorry. There's no other question.
Okay, all right. So thank you everyone for your time today. Thank you for attending this webinar. I wish you all a very good rest of the day. Thank you.
Thank you, Marwan, and thank you everyone for your taking time to be with us today. Alex Njoroge is the person to go to for any of these solutions, any follow-up questions you may have, any technical support that you need. Alex will be able to help you. Also, I believe that everyone here has followed us on LinkedIn and on our social media. We will continue we have another webinar with Andritsu that will be coming up next month. So please stay tuned and keep engaging with us for even more training and information. Thank you and do have a great afternoon, everyone.